Okay, so now we continue with the second video, which is buying inductor. Okay, so inductor is a bit tricky because you cannot just directly buy it, especially in the case of power electronic. Okay, so maybe we go here. Okay, so when it comes to inductor, okay, for power electronic application, okay, so you can have usually commonly two options. Okay, so this one, for this application you have low and low power, low in the inductance, low current, and this one is for, this one is N, and this one is low, sorry, not low, high inductance or high current. Okay, so you have two options. Okay, so for this option you can just directly buy. Okay, okay. Direct city LY buy. Okay, usually this one is using toroid. Okay, toroid, or I forget, axial, I think it's called axial type. Okay, but for this one you have to use a much more specialized. Okay, 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 specialized one, specialized component, which is usually we use ETD. Okay, and this one you have to build your own. Okay, so for ETD type you have to build on your own. Basically inductor, either you buy it directly or you build on your own. Okay, what is the difference? So like I said before, this one is, sorry, my PC is not working properly today. Okay, so okay, so this one low inductance, usually, okay, it's not specific, usually less than 1 millihenry. Okay, sorry, 1 millihenry is also quite large, 0.5 millihenry, and the current is usually less than 2 ampere. Okay, so this one usually you can just buy directly, but if more than that, more than 0.5 and more than 2 ampere, or more than 2 ampere, you have to make on your own. Okay, so this one is just a estimation, so you have to click the element 14 whether the component is available or not. Okay, so before I proceed, I will show you how to determine the inductance. Okay, so of course, same as before. Okay, so you have to look at the simulation, you have to measure the inductor current. Okay, this is the inductor current. Okay, let me pause this. Okay, so again, wait, so you have to look at the inductor current, and you have to test all the operating condition, 0.3 or 0.7 duty cycle, for example, for this, and then you have to look at the maximum current. Okay, for this for this study, maybe I set to this one is 4 ampere. Okay, so 4 ampere, and for inductor, of course, you cannot increase too much. Okay, so I suggest just increase a little bit. If 4 ampere, maybe become 5 ampere. Okay, so for this case you have to look everything. Okay, so there is two conditions actually here. Okay, so either the current is overshoot very high, and then something like this. Okay, or another condition is become like this. Okay, let me adjust it. Okay, so this is of course the T. So you have two conditions. Okay, either it is a very short transient or very long transient. This one is around maybe 10 millisecond. Okay, so 10 millisecond you don't need to consider this. Okay, the wire can handle it usually, but is more than 10 millisecond. Okay, for example, this one usually maybe the for motor it can be around 3 second, 4 second. You have to consider this current. Okay, so you have to look at this current. Okay, you have to consider maybe the steady state is also the same. Okay, 4 ampere. Okay, 4 ampere. Maybe this one is 8 ampere. 8 ampere, and this one also 8 ampere. This one don't need to consider, you just set it to 4. But for this case, very long transient, you have to consider the 8 ampere. So for this case, for example, you already calculate L, and of course you have to increase it. If example 2 millihenry from the calculation, okay, and then you have to maybe increase it a little bit, 2.5 millihenry. Okay, for this case you cannot just put the safety factor, because inductor is quite difficult to design. The larger is it, the harder it's designed. If you use safety factor, you can affect the design a lot. So I just suggest you add a little bit. Okay, not too little, but maybe I cannot say. Okay, just this one is just estimation. Okay, so and then the current, of course, for capacitor is voltage, but for inductor is current. Okay, so for this case I suggest you just put for because this is 4, I suggest maybe 5 ampere. Okay, so you have to find 2.5 millihenry and 5 ampere. So next step, if of course you can just go to the Cytron, usually don't have this, you have to go to online. So this is online. Okay, this is inductance. Okay, so inductor passive component. So you can search around fixed value inductor or toroid inductors. Okay, so this is toroid, basically like a donut shape, or fixed value inductor, also limited, or power inductor. Okay, so you can search power inductor. I suggest don't use SMD. SMD is basically surface mounted device. For UTM we don't have that. It's more towards the PCB. Okay, DIP is called DIP. So basically you have to drill a hole at the PCB and you insert the component. SMD is you just put it and solder it. So I suggest you don't choose SMD. Avoid SMD for UTM student. Okay, so choose this one. Okay, and of course the same process here. So you choose the Henry. So you can see it's not available. 1.5 millihenry is the highest. Okay, same as others, I think. Okay, you can go to toroid. Okay, you can look at the inductance, is also the same. Okay, usually is quite small. Okay, so maybe this one you can show the product. Okay, and the current, you have to look at the current also. So it's not written. Okay, if not written, you can click the datasheet. Okay, so based on datasheet, you have to look at the current. So this one is not very good, they don't show the current, I think. Okay, so there's no current, but usually the current is quite small. Okay, you can see the wire is quite small. So if this happen, like I said before, okay, you cannot use this one, low inductance, low current. Okay, you have to make on your own. Okay, If that happen, you have to make on your own. So to do this, you have to choose ETD. So just search ETD. Okay. So ETD is basically a transformer, something like a transformer. Okay. So ETD is just the shape. This is the shape of the ETD core. Okay. So you can see here the ETD, you have the size. Okay, 49 is the size, 49 millimeter. Okay, and same here. Okay, this one is ETD 44. The size is 44. The larger the number, the larger the size. Okay, so 3C90 is the core material, so no need to worry on that. But the important one, you have to choose the core. Okay, so this one there is no specific calculation on how to choose the core. Okay, the smallest one is ETD 29, if not mistaken. Okay, so 3029. Okay, sorry, I cannot find it, but okay, ETD 29, ETD until ETD 60, if not mistaken. So you choose one, for example, 44. Okay, the usually depending on your experience, actually, if you are 6 millihenry and 4.5, right, 4.5 millihenry, 4.5 millihenry and 5 ampere, you usually need to choose the big one. Okay, 49. Okay, 44 I think is still not enough. Okay, TD 49. Okay, this one. So this one, you have to look at the data sheet. You have to estimate whether the winding will be enough or not. Okay, so this is the, not this, you have to look at the, this one is the winding area. This is called ball beam. Okay, so you will wind the winding here. Okay, so you look at the ball beam, you measure it, and you estimate whether it is enough space or not. This is the area of the winding. So you're winding here, here and here and here and here. Okay, so this is the side view. You will winding here multiple layer. Okay, so how to know how many winding you need? So you go back to this, you look at the inductance factor. Okay, inductance factor AI. So 4.2 micro henry. So 4.2 you have to multiply. Okay, the formula is basically so L is equals to N squared divide by multiply by AL. Okay, so AL you take from here, which is 4.2 microhenry. Okay, so number of turn should be L divided by AL, okay, and then square root. So L, of course, 4.5 before, 4.5 divided by 4.2, right? Okay, 4.5 milli. So 4.5 milli means that 4500 divided by 4.2, okay, micro, because you have to make sure the unit is the same, 4.2. So you get square root here. Let me take a calculator. You get 32.7, okay, 7 here. Okay, so winding cannot be 0.7, okay, so it should be 33 winding. Okay, so after you look at the number of winding, you look at the wire size. Okay, so I suggest you look at the AWG, American Wire Guide. Okay, so I suggest you look at the image, look at the current. Okay, find out the current. Let me pause first. Okay, so you have to search AWG current rating. Sorry, there is no database, correct database to do this. So you can check your maximum current. You set it to 5 ampere, right? So 5.4. So AWG is 8. So after you look at 8, you look at the diameter. AWG 8 diameter. Okay, let me check this. So you can see here, you can just Google AWG 8 diameter is 3.1264. Okay, the problem is this: the wire is quite thick, it's quite hard to wind. So to avoid this problem, usually we have wire, the highest one is 1.5 millimeter. 1.5 also quite difficult to wind, so I suggest maybe 1. Okay, so 1 AWG, not 1 AWG, 1 mm wire. You choose 1 mm wire. Okay, and then you look at the okay, there is no data also, so I suggest 1 mm wire, I think around 2 ampere. So you just parallel the wire together. Okay, 1 mm wire parallel together. Okay, parallel 3 wire parallel together, and then you combine it, combine parallel wire, and then you wind into the inductor. So you have to use a specialized wire. Okay, so before we proceed with the specialized wire. Okay, so for the wire, you basically you just check 1 mm becomes like 3 to 4 mm. You measure here. Okay, you calculate whether it is enough or not area. So that is why you have to calculate the number of turn and the wire size. Okay, so just an estimation, is no real calculation you can have. Just try and error. Okay, so when you already choose the size, as for this case, maybe for me I suggest for 49 maybe. Okay, so you have to buy the ETD core. Okay, so for one transformer, okay, let me make another page. Okay, okay, so for a ETD, if you want to use a ETD, you have to buy 2 core, 2 clip. This one is only 1 ETD. Okay, 1 ETD, 2 clip, and 1 bobbin. Okay, so this one is just for 1. For this case, you only need 1, right? Okay, so for this case you only need 1, so you have to buy the ETD 49. Make sure you check the size. ETD 49, you need to have 2. Okay, and then you go down, you have, see here, clip. This one also you have to buy 2, and then the bobbin you have to buy 1. Make sure the size is the same, and I suggest the manufacturer needs to be the same. This one is Ferrox cube, so this one also needs to be Ferrox cube. If not, you maybe have a problem later. So that is how you buy a how to buy a inductor. Okay, either you can buy built-in, okay, using toroid, okay, or you have to do you make it yourself using ETD ETD type inductor. So ETD 49 core, you need to have this one, of course, element 14. You need to buy 1 set is also enough, because inductor also is quite difficult to damage. So you can just buy 2. Remember, one inductor is 2 core. Okay, this one is clip. Okay, and another one is bobbin. Okay, so this one is 2, this one is 1. And the link, of course, you have to copy this. ETD clip, copy this. Okay, another one is the bobbin. Okay, so this is the bobbin. Copy this, and then paste this. Okay, so now you complete the core. Okay, next thing, not only this, you have to also buy the enamel winding. So let me Google it first. Okay, so basically you have to buy a enamel wire. Okay, so Shopee is much more cheaper actually usually. Okay, so you can see here it's much more cheaper to buy from Shopee. RS also available, but it's quite expensive. And here I think it's also available. Let me check. Enamel wire. Oh, it's not available. So I suggest you, okay, this one 1mm. Remember, we have to choose the millimeter. Okay, so for this case you have the buy this one, and okay, 1mm. So this one is from RS. You just buy one. Okay, so you have to buy this also to make a inductor. Another thing you need to buy is poly tape, I think. So I forget the name. So basically this is the tape, the yellow tape. This one is not a normal tape, it is a specialized tape for the inductor. So let me check first the name. Okay, so basically it is called insulation tape. So you can just search in element 14 insulation tape and find this one. Okay, so you just click this. This is the insulation tape and it's quite expensive. Okay, it's actually a polyester film. Okay, so this one is very thin and very strong and insulated. Okay, so it's very good for making inductor. So of course you have to copy this. Okay, okay, and then element 14. Okay, poly tape. Okay, so just one. This one, okay, I forget to get total price. Or this one is price. This one is per price. Okay, so I forget also to write all the price. For this one is 72. I think this one is 35. Okay, and then of course you have to multiply this one multiply by this one. Okay, you get the price, you get the total. So you have to record all the price here, don't forget. Okay, okay, so basically this is the component just to make a inductor. Okay, it's quite complicated for inductor. Okay, and one more thing you have to know, that you have to check this. Okay, enamel wire 1mm and polyester is quite expensive, but it's usually available in the lab. So you can just check first, okay, in the lab, in power electronic lab, level 2 P7. Okay, you check whether this one is available. If available, no need to buy. This one is also, if available, no need to buy, because it is a lot. Okay, usually one student only use a little bit, they already buy it a lot, so you just buy it, use it in the lab. This one you have to buy on your own. Okay, so make sure you put the price here. Okay, it's not very, quite slow. Okay, it's okay. Okay, that's it, how to buy a insulation, how to make a inductor, buy a component for inductor. Okay, I forget one thing. Okay, if you search for inductor is not is still a small, you can just buy the toroid itself. Okay, this one is another, this one is just for small component only. Okay, toroid only. Okay, without the winding. So this one already have winding. Sometimes they also sell without the winding. I forget the name. I think it's just a toroid. Yeah, toroid core, I think. Maybe this one. Yeah, this one. Okay, so you can just buy the core. Okay, if you don't you want to make on your own, you just buy it. Okay, make sure you know the size. 77 is usually the size. Okay, you can check the data sheet here. Okay, that's it. Let me recap. Basically, you can if your inductor in current is very high, you have to choose the ETD. If not, you can buy the already available one. Okay, this one also has limit. I think it's around 7 to 8 millihenry, around 6 to 7 ampere only. If more than that, you have to buy a specialized inductor. This one usually you have to ask some company to make it for you. Okay, that one is another level. It's very high current, high inductance. Okay, so that one I will not discuss in here. Okay, that's it for inductor. I hope it will help you to make a purchase of inductor. Okay, thank you.